So, hey folks, this is me, Vishwasna, and this is the first show of Build Piper. And a lot of times, I've realized like, can I make it much more easier in terms of deploying anything into a microservice? That world is so huge, it is full of jargons. There are a lot of things that I and you don't know today. And I think Build Piper as a solution is something great. And this is our humble attempt in order to make sure that people understand, people realize that, hey, you know what? There's something beyond everything that we are talking here. Like, it's just the Dockerized piece of code going out to different environments and making it more accessible. I think that's the really big challenge that Build Piper is solving. And I think thank you so much, Naveen sir. Being on the show means a lot when we learn with a teacher like you. It's a lot of pleasure. It's something like we have realized that there is something beyond whatever we know today, and there is something that we get bored about. And I think Build Piper is such a cool technology, and I think Naveen sir is also an amazing standees in the communities, and I think it's an honor to be learning from him. And also, this show is just dedicated for all the basics, intermediate, and the advanced concepts to be covered based on your Build Piper, based on the DevOps, based on the Kubernetes, you name it, it's there. So thank you so much, Naveen sir, for taking the show. Means a lot.
Thank you so much, Vishwas. It's a pleasure and an honor to be with you on these talks. So it's really insightful for me as well. I also get to discuss and share my thoughts with you and everybody, and the conversations that we have are really delightful, and I really look forward to any conversation or any shows that I'm having with you. So it's
Sure.
such a wonderful experience for me.
So let's just go on with this. Like microservices in hype today, right?
Mhm.
Every company have their happy monoliths, but they yet want to migrate towards that microservice. It's not something which is cool, but it reduce the complexity, it reduce the efforts that they were putting in order to develop something. Like if one thing goes down, everything goes down in a monolith. But microservice is not like that. At least the business keeps moving. So all about that. So let's just start with this question of like, what was your first journey when you heard about the word called as microservice? Like, what was it all about, and how did you start learning microservices?
All right, so the first time I heard the word microservice or containers, funny story, it was actually when I was planning a session on DevOps, a DevOps 101 session that I was planning in my organization. So at that point of time, we were to cover all the concepts of DevOps, including the major tools that are being utilized in DevOps. So there, Docker was one of the tools in virtualization and containerization. There, I heard the words containers and microservices, and there I came to explore what actually a microservice is, and then I started growing my interest there. So from there, I started learning about what microservices are, how they function, how are they different from the applications that are currently being used in the organization. Why exactly do we need microservices in the first place? What's wrong with what we are having right now? So yes, from there it all started, and now here we are, just surrounded with microservices here, there, everywhere. So now it's the time where you don't even have to think about microservice. The word will come in front of you on its own.
Sure. That's how the industry is moving, right? I think
Exactly.
that's where I always used to say this. Once you talk about microservices, it's just something like you are adding more complexity into your system by building more microservices, because everybody needs to focus on the APIs, the security, the
Exactly.
DevSecOps strategies, motivating team to migrate from one service to another. Like, let's say they
Absolutely.
are in a payments team, they want to just migrate to this team or that team. It's something that is
So
there.
true.
Yeah, I think I
Yes,
think I think we have a great service wing as well, where we give a lot of services to other companies. Yeah,
absolutely. A lot of microservices are coming into the picture right now. Everybody
yeah,
is doing that shift. So, in its simplest sense, right now, microservices are almost equivalent to potatoes. You'll see them everywhere. They're present in every environment.
Yes, that's
So,
true. That's
no
true.
matter wherever you go, you'll find
Yes,
them.
that's true. I think yeah, I think ThoughtWorks came out with an amazing strategy. People came out with more agile methodologies of delivering something using microservices. I think we are doing pretty awesome. We are helping a lot of organizations build, deliver faster.
Absolutely.
There are more people who are yet to learn Kubernetes, but yet they are still deploying code for Kubernetes. I think that journey probably is going to be much more easier with us. And thank you so much, Naveen sir. The stage is yours from now on. You can go on with all the things that you wanted to teach us.
Thank you so much, Vishwas. So, yes, the agenda of today's session would be to give a brief about the microservices, what microservices are, how a microservice differ from a monolith, how their architectures vary, and what all are some of the commonly used and some of the advanced concepts that people are utilizing in their microservice based architecture. And that is where Kubernetes comes into the picture, because we need something to orchestrate, and
Hmm.
Kubernetes is something that is in everybody's head these days. So
Sure.
people eat Kubernetes for breakfast. So
Yes,
it
that's true.
is so that's where Kubernetes will come into the picture. And while we are going through the concepts, I'll try
Hmm.
to cover most of the concepts via demos in the end. And yes, there will be utilizing AKS as the cluster, Azure I'm utilizing as the cloud, and AKS is my Kubernetes cluster. So I'll walk everybody through the entire setup, my lab setup that I've done for today, and all the
Sure.
demos. I'll try to publish all these manifests that I have for my demo on GitHub, so that everybody can go around and play with those. So
Sure.
let's get started then.
I'll share your screen now.
Yeah, definitely. Thank
Sure.
you. Alright, so let me just refresh it once. Alright, I hope it is visible.
Yes, it is visible.
Alright, so starting off with today's agenda would be the introduction to microservices. So before I move on to microservices, one thing that all of us should understand is the existence of microservice. How did it come into the picture, and what was the concepts which were being utilized prior to switching on with the microservice based architectures. So microservices, as the name suggests, we are breaking down a service into micro components. We are breaking it down into smaller components. So how things used to work earlier is, we used to have a single huge application, and that application used to take care of everything. So how things used to progress earlier is, people used to have certain requirements. They used to share it with the development teams. The entire team will go through the requirement. They'll start building the entire project. The entire project used to be built in a single cycle. So there were a lot of components which were being tightly coupled. So it was a tightly coupled system which we were working with earlier. So a tightly coupled system is having its own advantages and its own limitations as well. Limitations being heavier on the advantages, which led us to the concept of microservices. So once I have the huge chunk of my application, it is easier for me to look at stuff, because everything is there in a single place. I have a single source of truth where I'll go and I'll check. My database is also on the particular server. Let's say I have a huge server where I'm running my application. So I know that this is the only server where I have to check. I have my entire application present there. However, there were certain challenges which people used to face when we talk about monoliths. So let's say if I have to make any enhancement in my application going forward. For instance, I'm building one e-commerce platform. That e-commerce platform right now has something called as a catalog. It has something called as a cart and a checkout portal. So these are the three portals which I'm having right now in my application. Going forward, I decide users should have their customized setups. They should have the place to log in, they should have the place to register, so that they can store the items which they want in their cards for later and just log in, browse them through, and either buy them or discard them. So in order to get that enhancement in my application, I have to revamp my entire application. So I am taking that huge chunk and I am rebuilding that huge chunk, which was a lot of effort, which was a lot of time to be consumed. And the risk of having errors anywhere in the application increases exponentially. So those were all the challenges which people used to face. So, some of the major challenges which we are familiar with. So, in order to get out of that bottleneck of revamping the entire application every time, the concept of microservices came into the picture. So, what we are doing in microservices is we are simply decoupling our system. I am, instead of having a big box at my disposal, I am getting the components inside that box out and I am loosely coupling them with each other so that they can communicate. However, they are not interdependent on each other. For instance, I have a front end for my application. I have an application layer for my application where all my business logic reside. Now, if there is any front end related change, for instance, I am changing the banner that I'm having on my welcome screen, it should not force me to again build my business logic or revamp or redeploy my business logic. I should be independent of my front end part and I should only make changes in my front end, deploy that change, and that change should reflect on my application. So that is what my loosely coupled system looks like in its simplest sense. So the ideology was to decouple the system, loosely couple the system, so that we have different components and those different components get along with each other. They can communicate with each other, yet they are still not dependent on each other. So that is how the loosely coupled architecture came into the picture. So now instead of having one server where I was having my front end, my application layer, my database, anything and everything was residing on that server. Now, for instance, say I'm having three different servers. I have my web server which is hosting my front end. I'm having one application server which is hosting my entire business logic, and I have my database which is storing my entire data. So right now I have three different machines for one application. These machines are communicating with each other for getting the data to and fro from the client and to the client. Still, now I have the independence of individually maintaining these different layers. So in our most popular terms we call it a three-tier application. So that is how we divide our three-tier application in three different components. So right now my system is already loosely coupled. However, we are still not exactly talking about microservices. Right now we are still having that big builds, let's say big Java builds, big war files being deployed on all these servers. So we are still not at the microservice layer per se. We have loosely coupled our system, but still we are going with the conventional method of application deployment and management. So the concept of microservice is we are giving the entire application, we are wrapping the entire application into something more manageable in the sense something that is lightweight, something that is easily available to ship. I can deploy it anywhere and everywhere I want with ease, and the manageability also increases for me. And to facilitate that culture, that environment, we have something called as Docker, that is the containerization platform. So that is where containers came into the picture, and these containers are hosting all our microservices. So what we have done is we are doing the entire build processes, and we are creating a minimalistic image or a minimalistic microservice, or that small chunk which we are shipping to any platform which we want, be it Docker Hub, be it my self-hosted registry. So that is where I am keeping all my images. So in that sense, we are now even piping down the management of our application. So earlier, where I have to build my entire application, I have to keep that jar somewhere and manage that jar manually. What I have done is I'm building the application, I'm creating the jar,
Naveen sir, were
and
you
using
able
the
to share the screen? Are you changing the slide? Or are you in the monolith only?
no, I'm right now I'm not changing the slides.
All right, fine.
Yes. So yeah, the containers that we were discussing just now. So what we have done is, instead of managing that entire jar, what I have done is I am building the jar and now I am keeping it in a container that is managed by a container platform. So what I am doing is I'm building the jar, I'm placing that in a image, I'm creating an image out of it. And that is pretty much equivalent to creating a image or snapshot of my virtual machines that we are having in the cloud. So in the same sense, we have the image for our application created and we are shipping that image anywhere and everywhere we want. And using that image, we are creating those tiny containers on our systems, which are helping us optimize our resource utilization and our application management. So that is that will be a quick brief of how things used to be and how things are progressing now, where we are actually talking about microservices. So if I talk about simple standard architecture, how microservices are, so this is how things look like in a microservice based architecture. We have different components. Every component is broken down into a microservice, and those microservices are loosely coupled via, let's say, different API calls, different connection strings. Using those interfaces, they are connected with each other. However, they are still not dependent on each other now. So if I have to, let's say, update this microservice, I will only be updating this microservice. I will not be touching the entire system. My entire system will remain in the same state. So that is the advantage that we get with the microservice. So a broader example of the architecture of microservices. So we have our microservices and we have loosely coupled our databases as well. Now, these databases we can have in the form of microservices as well. We can have as our self-managed or cloud hosted. So that is completely up to us. It depends completely on your requirement, how you want to manage it. So multiple microservices can also be attached to a database. A single microservice can have its own database dedicated, and there could be microservices which do not require the database at all. For instance, any microservice that is dealing with my front end, it directly does not require a database of its own. So I will not be having any database configurations there for my front end. So that is how we segregate or loosely couple our entire system with the help of microservices. And that is one of the primary and major advantages which microservice based architecture is providing us. We have a more optimized architecture in terms of resources. We have a better control over our environment. We have a loosely coupled system enabling us to migrate, manage all our components individually without hampering the integrity of my entire architecture. So that is some of the major advantages which we get from the microservice based architecture these days. Now, with great powers come great responsibilities. So yes, there are certain limitations which microservice do hold. So these are some of the components which we have to be careful about. So if I give you an example, for instance, I have one application which is deployed on one machine, and that machine is the only machine which I have to manage. On the other end, I'm having 5 microservices deployed on my system, on my environment. Now, on the first scenario, I have to manage just one machine which is holding my entire application. And that application, that system is the only system which I have to manage in terms of security, in terms of maintenance, uptime, anything and everything. On the other hand, I have 5 microservices. I have to make sure all those 5 microservices are up. I have to make sure their security is in place. I am securing my microservices as per the standard of my system. I am exposing only those microservices which are required to be exposed. I'm not needlessly exposing all of my microservices. So yes, the management is something which increases when we move from monoliths to microservices, because we have more components to monitor, we have more components to track now. So that tracking do increase, but yes, this is a cost which we are willing to pay based on the advantages and the convenience that it is providing us. We have a better managed system at our hand these days. So that is the power of microservices, and that is how it is making our lives easier and giving faster deployments to the market. Our time to market has reduced drastically when we have moved to a microservice based architecture as compared to a monolith based architecture. So that is our primary idea of having microservices. Now, when we talk about microservice, yes, these components do come in our heads. We have microservices everywhere. We have, different terminologies being utilized. We have services everywhere. We have deployments everywhere. So yes, these are some of the components which we will go through for our microservices. And this is usually a visualization of how the interconnection of service works, or how generically we have the microservices in place. We have multiple microservices communicating with each other via different APIs, via different connection strings. So that is the bonds between all these microservices. So just the connection strings or the API calls are what is binding these microservices. So they are not dependent directly on each other. So that gives us the freedom of managing, updating, or deploying a new microservice in our system without worrying about the state of my entire architecture. So when we talk about microservices, yes, two words that come into mind are containers and Kubernetes. So these are the buzzwords these days. Anywhere, everywhere we go, we will hear containerization or Kubernetes or Docker being used. So yes, Docker, containerization, and Kubernetes orchestration. These two components are helping us greatly in our microservices journey. They are enabling us to get into the culture of microservices in terms of application building and deployment. So this is a slide for how Docker as a orchestration, Docker as a containerization platform works. So what we are doing in Docker is we are practically building images and containers. So when we talk about a Docker image, we can easily relate it to any standard image for our virtual machine that we are having, or any standard image disk that we used to have in earlier days for our Windows or our operating system. We'll get that disk and we'll spin up a new OS, and we are good to go. So that disk used to hold the image of our entire operating system. Or if we talk about cloud these days, we have virtual machine images already present in the marketplace using which we can create different types of virtual machines. In the same fashion, using Docker, we can create images having different capabilities, having different components incorporated in them, and we can easily ship them out. So that is how Docker is helping us, building minimalistic images using which we can create our containers which have all the required components for my application, and it also optimizes the resource consumption of my machine. So unlike spinning up the entire virtual machine or an entire server to get things done or deploy my application, now I just need a small chunk of my operating system where I'll be running my container. So the ideology behind having containers or microservices to optimize that resource utilization first for our machines. We do not require the entire system for one application or one microservice. I can run multiple microservices thanks to these containers. We can have multiple services running on one machine, And that is what this diagram is depicting. So what we have is we have Docker daemon. Docker daemon is responsible for making all the interactions with the Docker APIs, which helps us create all those images. These images we create using something called as a Docker file. So there we create these images. These images are nothing but different layers which are also loosely coupled. So an image is a combination of multiple layers. There is a base layer that is always the operating system. So any and every image that you will be using, be it a Java image that you're utilizing, be it a Redis image that you're utilizing, Postgres image that you're utilizing, every image will have a base image of the operating system, because in the end we do require an operating system where all those components would be deployed. So how it is benefiting me as compared to having one complete server spun up, or having virtual hosts running on my machine, is I can create the image, I can have all the components built, and once I am done with those builds, I can copy or I can transfer just the artifacts which I require to my image. So my image only contains the components which are required for my application. It will not contain the additional components which will increase the size of my image or my application altogether. So for instance, if I take the example of a standard Java application, a Maven application we build, so that Maven application, while it is building, it will resolve a lot of dependencies. It will get a lot of jars. Those are the libraries which it requires to compile and build the application. Once the application is built, I will be provided with one artifact. It can be a jar, it could be a war, or it could be any AR also, depending upon the type of application which I'm building. So in the end, once my application is built, I have the final artifact. I do not require those binaries anymore. I do not require those libraries which it resolved by building the project. I only require that one jar or one war file in my system. So what I do is I get that jar or war file and I copy that in my image. So my image is only having that final artifact, and I am leaving behind all the dependent libraries which are not required anymore. So which is optimizing the size that I am taking on my machine. So now instead of utilizing, let's say, 1 GB or 2 GB, I'm only taking up 30-40 MBs. That is my final artifact. So that is how drastically it helps us reduce the sizing. That is the entire essence of creating images, and with those lightweight images we create our lightweight containers. So that is the entire ideology behind Docker. Now we know that Docker is gradually replacing our virtualization, how we used to work. We used to have different hypervisors sitting on our machines to run different operating systems. So we used to have Oracle VMbox, so VMware. Those are some of the famous hypervisors which were being used earlier. So what actually differs when we talk about a hypervisor and Docker is hypervisor has its own layer of virtualization which sits on top of my hardware, and then it has the guest OS, and there we have all the resources. However, when we talk about Docker directly sits on my host, and there I have my Docker engine, and Docker engine is actually doing the entire task. It is directly utilizing the host OS and help us build those images and binaries that we require. So that is why Docker is fast and lightweight. So I do not require 3 or 4 gigs of free space in my machine in order to run Docker. I do not require that. So using all those components, Docker enables us to build the applications faster. Now I do not require the entire system like earlier days. So if I have to create an application, or I have to, let's say, just explore an operating system, I want to explore Linux for instance. So instead of having one hypervisor provisioned and on that hypervisor having my operating system, I can simply get Docker there. I can download the image of any Linux operating system, any Linux distribution, and I can go in that container, spin it up, and I can start playing around. So it's that simple. So that is how it is optimizing the way we work. So it is all about optimizations in different verticals. So this is the same concept which we just discussed. So in order to create an image, we have something called as a Docker file. It's a declarative small piece of file which we write where we set the different layers of our image. We have different commands which we trigger in our Docker file. We write those commands. Once we execute our Docker file, the Docker file builds, and finally we get our image. So image is, as we discussed, is nothing but a set of layers, and every command that we execute in a Docker file comprises of one layer in that image, and all those images combined make the final Docker image or the container image. Then we ship that image to any container registry. Now that container registry could be Docker, that container registry could be Nexus, that container registry could be Artifactory, or you could have your own self-hosted container registry as well. So you publish those images in your registry, and once your image is out there, now it is free for you to use. You can pull that image, spin up a container, get your application going. It's that simple. So this is the entire process. We create a Docker file, we build the Docker file, we create the image, we ship the image, and then we run our containers. So it has simplified the way we work with applications a lot, by a tremendous amount. So that is what we get from containerization. Now, when we talk about containerization, the second thing that comes into our mind is Kubernetes. So, yes, Docker is good. Docker is a good platform to work with containerized applications. However, Docker does has its own limitation when it comes to governance and when it comes to running HA setup for our entire environment. And that is where we required a more optimized orchestration platform, and that is where Kubernetes comes into the picture. And this is where the microservice deployment and all the hocus pocus starts. So with Kubernetes as the orchestration platform, we get the required components, we get those required facilities to enable us to deploy those microservices, deploy these containers, and manage them better. So Kubernetes provides us that entire environment where we can have our managed platform, our managed setup for all our applications. So we run our images via Kubernetes on the Kubernetes clusters that we create. So in Kubernetes, there are a lot of components which Kubernetes comprises. Today in this session, we'll be discussing few of the components, and those components will be walking through. So some of the most commonly used terms that you'll hear in Kubernetes are deployments, services, nodes, and pods. So these are the basic elements you can say whenever we talk about deploying a microservice. So we will be having a deployment for that microservice, and these are the components which we will discuss going forward. So we have our Kubernetes cluster. The Kubernetes cluster is divided into two components. There is a master plane, and then there is the node groups or node pools. So the master plane holds our API server. API server is responsible for communicating with our slave nodes or our node pools. Node pools have their container runtime and kubelet as the component running inside them. And the API server continuously communicates with our node pools. So anything and everything that we executes on our node pool. So in the end, it is going to our node pool. So any command that is triggered from the user goes from the API server through the kubelet to our nodes, and then it is executed. So this is a standard architecture, a minimalistic architecture of Kubernetes. So HCD is the default database that Kubernetes uses to store all its objects, and all the objects are stored in the form of key value pairs. So that is how the storage works, or this is the standard architecture of our Kubernetes cluster. So nodes are nothing but nodes can be your virtual machines, nodes can be your scale sets, nodes can be your Docker containers as well. So these nodes are the actual back, you can say the muscle of your entire cluster. So the nodes are my muscle because that is where the entire execution, the actual executions will happen. My pods will run on my nodes. So the compute, the memory, the CPU, my nodes would be providing to my applications running on them. So that is my standard Kubernetes architecture. So as you can see, these are this we can say it is my node pool or a node group. So a node pool or a node group is nothing but the collection of multiple nodes. So we can also segregate our nodes based on our utilization or the different, you can say, business units they are catering to. So thanks to cloud, these days the management of a Kubernetes cluster is really, really easy. It's just a single click and you have your entire cluster up and running. So if we talk about Azure, in Azure we have AKS, Azure Kubernetes Service. In AKS we get node pools. So in node pools we have a group of machines clubbed together. That is my node pool. So I can have different node pools based on my requirement. For instance, let's say I have two different engagements. I have a marketing engagement and I have a finance engagement. So the finance engagement requires their own dedicated set of applications which would be running for them. They have their specific requirements. For instance, all the finance based applications would be CPU intensive. And then I have my marketing engagement, which also requires its own separate set of applications that needs to be run, and those applications are memory intensive. So in this scenario, with the concept of node pools or node groups, I can have different node pools created with different set of machines in each node pool, and I can allocate these node pools to different set of deployments that I'll be doing in my cluster. So this is one of the advantages that we get from our node pools or node groups. We can group different machines into under a single umbrella, and we can run a specific type of workloads on those machines inside my node pool. So that is the concept of node pools or node groups. If we talk about AWS, we have EKS there, Elastic Kubernetes Service, and there we call it node groups. So it's just the terminology difference. In the background, the functionality is similar. So now we talk about various offerings that Kubernetes does for us. So Kubernetes provide a whole lot of services, a whole lot of components to us. In its base, it provides us the facilities to deploy those microservices, deploy those containers in the Kubernetes environment. My cluster is at my disposal to get those microservices deployed. So we do get different other components. We do get storage that is being provided by Kubernetes. We have different objects which help us or which enable us to get those storage components incorporated in my application. We have volumes, we have persistent volume claims, we have storage classes, we have services, we have load balancing provided with Kubernetes. We have cron jobs which we can schedule in Kubernetes, so we can have our scheduled tasks planned in our Kubernetes cluster. So Kubernetes also provides us the concept of secrets. Kubernetes also provides us the facility to maintain the state of my application. For instance, if I'm running an application, I will deploy it with the concept where my application would be required to maintain a certain state. For instance, my application should have at any given point of time two instances running. So Kubernetes will ensure that my application at any given point of time is having two instances running. Unless or until there is anything that is breaking in my application, which in turn is keeping Kubernetes from spinning up that another instance, Kubernetes will make sure that I get those two instances at any given point of time for my application. So these are some of the features, some of the facilities that Kubernetes is providing us in order to better manage, better deploy our application in the different environments. And these are some of the components which we'll be discussing today. And this is a tilt shift of how we moved from monolith to microservice. So, as we discussed in the very beginning, so in the monolith, we were having everything and anything in the same box, everything placed in the same machine, tightly coupled system. We moved to microservice based architecture, we moved to a loosely coupled system. We got more independence in terms of managing our application, managing our services, and which in turn got us to the entire ideology of having a loosely coupled system with our microservices. And to provision that microservice based architectures, we get Docker and Kubernetes to back us up there. So this diagram depicts all those components, how we are transitioning from monolith to microservice based architectures, and what all components are enabling us to move there. So now this is one of the components that we'll be discussing in Kubernetes, that is RBAC. This is role-based access control. So now before directly jumping onto RBAC, we'll just go through some of the basic concepts in Kubernetes and what those components are for, and then we will be moving ahead with the other components. So, with that being said, let's move on to our demos. And first of all, I'll give you a walkthrough of my lab setup, what currently I'm having for today, and what I will be going through. So let's move on ahead. What I have is a Kubernetes cluster. I've created a Kubernetes cluster, and Azure is the cloud which I am utilizing. And in Azure, I've created one Kubernetes cluster. It's a simple cluster, nothing too fancy. This cluster is having a single node. So based on the lab setup, I have not kept it to any higher configurations, just a single node pool. As you can see, it is just having one node pool, and that node pool is having a single machine. So I have a node pool and my machine is ready. I have a single machine, and this Kubernetes cluster is having two additional components. This Kubernetes cluster is Active Directory enabled. That Active Directory enabled cluster will help us through our demo in the RBAC. While we'll be discussing RBAC, at that point of time, we'll see the significance of an AD enabled Kubernetes cluster. And talking about this AD enabled Kubernetes cluster, I had done a separate workshop for the entire Active Directory integration with Kubernetes AKS. So that is something that I've already done in one of my previous workshops. We'll provide those links as well. So it is AD enabled, and the other thing that I have enabled in my cluster is the integration with Azure Policies. So how policies will come into the picture, this is the another component which we'll discuss at the time of governance, where we'll see how we can get the governance in our Kubernetes cluster in place. So that is where we'll be discussing webhooks. So there we'll have a demo for validating webhooks and how they help us enable better governance in our Kubernetes cluster. All right, guys. So with that being said, this is the lab setup that I am having, and all the demos which I'll be providing you guys. This is the only setup that you require. No additional component is required. So just an Azure subscription, AKS cluster, enable it with Active Directory, and enable the policies. So these two components you can directly do from the UI as well. It's pretty simple. It's just a click, a single click execution. You just tick on Active Directory enabled, save it, it will integrate with Active Directory. All right, so now let me just show you the setup. So I have different manifests, and these manifests will be utilizing for our demos. So let me just close all the additional manifests. All right. So now in order to connect with any Kubernetes cluster in Azure, it's pretty simple. You just go here and click. You need Azure CLI on your machine, And with that Azure CLI, you have to be logged into your Azure account first. So once you're logged in, you just have to set the subscription and then get the credentials of your AKS cluster, which will just add the kube config file of this Kubernetes cluster in your machine. So this is the entire setup and requirements. So we'll walk through different components one by one. We'll discuss the component and then we'll have a demo of that component. So we'll start off with the very basic components, that is our deployment. So the reason I'm taking deployment directly into consideration is it will cover two other remaining concepts that we are having. That is a replica set and pods. So to have replica set, I have one for replica set also. So we'll go through pods, replica sets, deployment services, and then we'll take it forward. So when we talk about Kubernetes, so the smallest entity that you can deploy in a Kubernetes cluster is a pod. So pod is nothing but a virtual component hosting your container inside. So when we talk about Kubernetes, the objects, the deployments, the replica sets, the pods, all these components are in turn deploying and running your containers only. So when we talk about pod is just that logical object which is hosting your container in turn. So that is the smallest unit that you can deploy in a Kubernetes cluster. So that is a pod. And post our pod, we have something called as replica set. So earlier we used to have replication controllers as well. So when we talk about replica set and replication controllers, there is just a minor difference which we'll discuss. So when we talk about replica sets or replication controllers, both these objects ensure the state of my application, which we discussed a little while back, that Kubernetes ensures that my application is maintaining the given state in any given point of time. So that state maintenance is something that comes from our replica set or our replication controller. So in our replica set, we provide something called as replicas. That is the number of replicas. That means the number of instances or the number of pods that should be running for my application at any given point of time. So here I have provided the replica as 2. That means when I deploy this replica set, I will be having 2 instances of my application running. And even if I try to delete one forcefully, it will again spin up. So that is something which we will validate in our demo. So that is what a replica set is for, or a replication controller is for. So this object ensures that state maintenance of my application. So the primary difference that falls between a replication controller and a replica set is replication controller was used earlier and it is an equity based object. So there we have something called match labels and match expressions. So when we talk about replication controllers just work on the labels, the match labels, in order to establish the connectivity with the underlying pod. So if you see in our containers, we have the name provided and there is a connection between different objects, and those objects connect with the help of labels in Kubernetes. So when we talk about a replication controller, it just works on the match labels, that is an equity based object. And when we talk about replica set, it is a set based object, so we can have the expressions incorporated in our replica set. So that is the primary advantage which replica set gives us over a replication controller. And these days we are utilizing replica sets instead of replication controllers. So here we have the match expression where we provide the key, our operator, and the value. So based on the entire expression, it will pick up the application. So if you see, we have provided the in the labels, we have given one label as tier, and the tier is front end. So we have provided the expression that if the key is tier and in that key this value exists, n means apart from this other value can also exist. So this value should be there, then it will pick it up. So this is the match expression, or how we provide expressions in Kubernetes. So this is what a replica set looks like. So in this replica set, what we are doing is we are simply telling this replica set to spin up two replicas. For my Nginx application, we will be deploying one Nginx container using the Nginx image, and for that Nginx in the container, port 80 would be exposed. So what we'll do is we'll go ahead and we'll deploy this replica set. For this, I've already created a namespace as front end. So if I show you my namespaces,
Yeah, like when I look
so you
at
can see
these
I've
topics
already
which are coming up, like whatever you are saying, I feel like these are the concepts which are there in Unix, hidden somewhere, but now
yeah,
brought into the world by all these Kubernetes and things like that.
absolutely, absolutely. So it even before Docker was introduced, containers were there. In Linux,
Yeah,
this was
1970s.
exactly Linux already was having the concept of containerization, namespaces, and having those caps on the resources. So with
Hmm.
Docker and Kubernetes being introduced into the picture, it has been more easier for us. They are enabling us do all these tasks without that heavy lifting. So they are encapsulating, all that heavy lifting which is required to provision these components. So
Yeah.
it has made it that much easier for us. So we have that layer of abstraction now, and that
Hmm.
abstraction is helping people move towards the microservice based architecture way faster.
Yep, that's true. That's true. Even some of the people that I hear about microservice, where can we lift the application from the status of monolith to a microservice?
Yeah,
You know what? Just go back to the Unix, learn all these, and now think about
exactly.
architecting new solution on it.
Absolutely, very well said. All right. So moving on ahead with that demo. So we have the namespace already created front end. So let's see if I'm currently having anything in my namespace. So I'll check for any deployment or any replica set that I might be having. All right. So right now we don't have anything explicit running in our namespace. So first of all, what we'll be doing is we'll deploy our replica set. So it is that's right. So for that we'll use kubectl apply. All right. All right. So our replica set is created. Let's check. All right. So now, as you can see, our replica set is deployed. The desired state is 2, the current state is also 2, and the ready count is also 2. So this replica set will ensure that at any given point of time, this desired state and this current state should match. So let's see our pods. All right, I'm facing some network glitches because of which sometimes the connectivity a bit slow. So pardon me for that, please. All right. So now, as you can see, we have two pods running, which was the requirement for our replica set. So now what I'll do is I'll simply delete one of the pods. So let me just delete this pod. So I'm deleting this pod. Pod is deleted. Now let's check the pods. See, as soon as I deleted this pod, it spun up the other pod. And if I check my replica set, the state, current state, and desired state will also match. So this is what my replica set ensures. So it ensures at any given point of time, the state of my application should remain what I want it to be. If I want two replicas, there should be two replicas. If I want one replica, there should be one replica. If I want 10 replicas, there should be 10 replicas. So this is what a replica set is, and this is how a replica set functions. All right. So now we'll move on ahead to our next component. So I'll just delete this. Alright, so our replica set is deleted. Let's check. So till the time it opens up, the second component that we'll see is deployment. So what a deployment is, deployment will do is, so deployment is also similar to what my replica set does. So deployment will also deploy my container. It will also ensure that I have the replica. So what a deployment will do, it will deploy my container. It will deploy my replica set also. So I do not have to explicitly define my entire replica set configuration. I just have to provide the replica count here. And it will make sure that replica or those number of instances are with me at any given point of time. So the next component that we'll be deploying is a replica, a deployment. So if it is able to connect, it's not okay. So see, we don't have the replica. The replica set is deleted now. So now we'll just deploy our deployment. My bad. All right, now let's see. See, our deployment is ready. Deployment is up to date. Let's check our pods. So our pod is also running. We told the replica count should be 1. So the replica count is 1. We are just having a single pod running. And our deployment is also functioning as expected. Uh, there are some issues today with the connectivity regarding my portal and my command line. So this was our replica set and our deployments. Now the next component that comes into the picture is a service. So now when we are talking about a microservice based architecture, we will be having multiple pods running for my application. So see, as I told you, this deployment created the pod and the replica set also. So when we talk about our microservice based architecture, there we have multiple pods running. So it won't be in the actual scenarios where we are having just a single pod running. We'll be having multiple pods. Now, in order to connect with these pods, communicating to an individual pod is a great overhead, and that is something which we do not want. So to mitigate that challenge, Kubernetes provides us with the concept called as a service. So the service acts as a load balancer on top of our pods, our deployment. And now instead of directly targeting this pod, I will target the service that I have deployed. The service will in turn go to that deployment, and that deployment will in turn go to the pod. So now what advantage it provides me is the scenario that we checked earlier while we were discussing replica set, where I deleted one of the pods. So let's say I'm having two pods, pod 0 and pod 1. For any instance, let's say my pod 1 crashed. Now my pod 1 is restarted as pod 2, and my application is communicating with pod 0 and pod 1. Now pod 0 is there, no problems there, but pod 1 is no longer there. Now I'm having pod 2. So if my application will try to communicate to pod 1, it will start getting errors, it will start getting failures. So to avoid that, we have service. So that service pretty much acts as a load balancer on top of our pods. So it sits on top of our deployment. I will be communicating with my service. My service will be going to my deployment and then to my pod. So this is how I am streamlining my communication with my application. So it is similar to what we are having in our standard scenarios, where I have deployed my application on two servers. Now, rather than sharing the IPs of those two servers, I have spun up a single load balancer in front of those two servers, and I'm sharing the IP of that single load balancer to my end client. So my end client don't have to worry about whether I'm running 4 machines or 10 machines behind the scenes. He's having one single point of contact using which it is communicating with my application. So that is what a service is doing. And the way service is interacting with all these components, the deployments and pods, is with the help of labels. So in our deployment, you can see we have provided it a label of nginx-app. And Kubernetes service, the service that we'll be deploying, is also communicating or connecting with the objects having labels nginx-app. So now we don't have to worry about how it will communicate or how it will connect with the deployment in pods. That is being handled with the help of labels. And that is the major significance of having labels in all our objects in Kubernetes. So now when we are talking about service, we have three different type of services, four type of services actually. So in general, we usually deal with three type of services. The fourth is not very common and not very often used, but yeah, I'll just give a quick walkthrough of that as well. So the first type of service that we have is cluster IP. So any type of service, be it cluster IP. So the three major types are cluster IP, we have node port, we have load balancer, and the fourth type is external name. So any type of service, be it a cluster IP, be it a node port, be it a load balancer, any type of service that you create, there always be a cluster IP for that service. So what a cluster IP type of service is, whenever you are deploying a service and you want that service to be accessible within your cluster only, that is, you are creating an internal service which will only be accessed by your pods, your deployments within the cluster. In that case, for instance, if I give you the example of a Java based application, in Java we have a discovery server called Eureka. So when I'm deploying Eureka, let's say I just want the internal services to interact with Eureka. So I'll create the Eureka service of type cluster IP. Now, what will that do is it will give it one internal IP, and any deployment or any pods inside my cluster will be able to communicate with that Eureka service. But I will not be able to communicate with that Eureka service from outside or from the internet. So that is what a cluster IP type service is. Then our next type of service is node port. Now, when we talk about exposing our service to the environment, to the outside world, at that point of time we have these two type of services. We have a load balancer type of service, and then we have a node port type of service. So now when we talk about a node port type service, what the node port service is doing, it is mapping an actual node port, the port of my node, with the port of my container, so that I can access my application from my node's IP at that specified port. For instance, the port starts from 92,000. So from 92,000 there is a range. So let's say I am exposing my application on the node port 92,000, and the IP of my node port is, let's say, 20.13.4.56. So on this IP at 92,000 port, I'll be able to access my application. So this is what a node port does. So it will expose my application on my node at a given port. So this is what a node port does. This next type of service is load balancer. Now this load balancer type of service is mostly used when we are dealing with our cloud-based Kubernetes clusters, be it AKS, be it EKS, be it GKE, or any other cloud-based Kubernetes platform. There we are mostly utilizing the load balancer type of service instead of node port, because node port is not very effective there, because mostly we are having our private nodes and they won't be having any public IPs. So instead of having those ports, plus we have a range of those ports, so we only have a limited number of applications which we can expose. So then load balancer comes into the picture. So in load balancer, what happens is, whenever we are creating a service of type load balancer, an external IP is allocated to my service. That external IP is nothing but a load balancer that is spun up on my cloud environment. So an actual load balancer will be created. That load balancer IP will be allocated to my service, and then I'll be able to access my application from outside the environment. So in our load balancer service, a load balancer is created. That load balancer is in turn mapped with my service, and that service in turn is mapped with my actual deployment. What happens here is we get an external IP. We get an external IP. This external IP is used by the client or the end user. They are the people who are accessing this external IP. However, this external IP cannot communicate with my cluster internally. So in order to communicate with the cluster internally, every load balancer or every external service will be having the cluster IP. So even if it is a service of type load balancer, it will still have the cluster IP, and that cluster IP is required to actually communicate with my application. Using that cluster IP, it will enter into my cluster, go into the node where actually my application is deployed. So this is the standard flow of how the communication actually happens when we have a microservice that is exposed in the Kubernetes cluster. So even if it is a load balancer type service, we do get the public IP. Yes, we get the external IP, but that external IP does not facilitate us to communicate with the cluster internally. That external IP is actually in turn mapped with the internal cluster IP, which is in turn communicating with our nodes where our actual application is deployed. So this is how the actual communication happens, and this is how the actual flow works. So in this example, we are having a load balancer type service, and there I'll show you the service will have both an external IP and a cluster IP. So now let's deploy our service. So we are already having our deployment in place, so we'll just quickly deploy our service. Alrighty then. Alright, a service is created. Let's have a look. Alright, it will most probably time out again. So we'll trigger it one more time. Alright. There it is. So now, as we discussed, this is our service. This service is of type load balancer. There is an external IP. This external IP is in turn mapped with this cluster IP. So me being the end user, for me, this is the only thing that matters. I need this IP. Once I hit this IP will in turn communicate with this cluster IP. And there is also one more port, that is our net port, where this cluster IP is running. So it will communicate with the cluster IP, and from the cluster IP, it will be able to get into my nodes where my actual application is running. So this is the entire flow. Now we have this external IP with us. So using this external IP, we can access our application. So let's see if our application is available. Yes. So now as you can see, we have Nginx up and running on our external service. And this is nothing but a load balancer. So let me see if I can show you that also. It's not required. In the portal, if I search this, so you see this is a public IP. So a public IP is created when I triggered the service of type load balancer. And this public IP is in turn attached with the actual load balancer that is deployed after this service was triggered. So the portal is also acting up on. So see, this is our public IP. This is the IP which we used to access our Nginx, and it is associated to this Kubernetes. This is a load balancer. So as you can see, we have the load balancer. This IP is attached with this load balancer. So if you see the front end IP configurations, you see this IP is attached. So this is how the entire flow works when we are deploying service. Now I think we can delete these. So let me just quickly delete all this. Service goals and then deployment will go. Alright. Already deleted. So now that we are clear with the standard concepts of Kubernetes, the major components which we usually hear, so now let's step things up a notch. So the next thing that comes into our mind is when we are talking about microservices, when we are talking about loosely coupled systems, we are talking about more optimized system. And one thing that comes to mind when I'm talking about a more optimized system is my resource utilization and my resource allocation. So with a microservice, I do expect it to consume less resources as compared to a monolith. Because if it is utilizing the same amount of resources, then I am actually defying the entire notion of utilizing a microservice. That is something which we do not want. Now, there are cases when we are working in our production grade environments, there we cannot let our microservices run loose, because as my application functions, as my application grows, so there comes certain scenarios where my application will start consuming more resources, and I want to put a check on that. I want to put a limit over that. I do not want my microservice to exceed these number of resources, or I want a certain level of governance. I don't want my namespaces to be cluttered with a lot of pods or a lot of config maps. I want to restrict that number. Let's say in any given namespace, I just want 2 or 5 pods to be running. There should not be more than 5 pods running on namespace. So those are the components which we take care with the help of resource allocation and utilization in Kubernetes. So we can have those checks, we can have that governance in place with the help of which we can manage our resources better. So this is what we will be discussing now. So let's move ahead with our resource allocation. So we will be discussing two type of resource allocations. First is which is specific to the resources, the resources in the sense Kubernetes objects. For instance, how many pods or how many config maps I want to restrict. So it is not just about the CPU and memory consumption of my applications. I can also restrict the number of pods or config maps that I deploy in a namespace. So that is also something which we can control with resource quotas in Kubernetes. So we'll be going through both. We'll be going through the object-based resource quotas, and we'll also be going with the resource-based resource quotas. Is it able to delete or not? Okay, right. So now let's move on to our resource allocation part. So now first what we'll go through is we'll go through the object-based resource quota. So what we do in resource-based resource quota, and this object-based resource quota, we specify that these are the number of resources which I want in a given namespace. Right now we are having one namespace front end, And in this namespace, I want that there should only be two pods deployed and only one config map which should be deployed there. I do not want anything more than one config map or anything more than two pods being deployed in this front end namespace. So this is what we will see now. So I'll deploy this. This is our. So now my resource quota is deployed. We can check this resource quota, get quota, and then the namespace. So now as you can see, we can see if there are any quotas specified in our particular namespace. So in our front end namespace, we have deployed a resource quota and it gives us the requests of one config map and two pods. So now let's see how effective this thing is. I have config maps. I should have config maps. Alright, so I'll deploy the config map. I can create two config maps here. That would be. Let me just quickly create two config maps. CM1, and then we will create another config maps. Alright, so now we have two config maps in place. Let's try to apply them. CM1.yaml. So now as you can see, there was already one config map, and because of which my quota is already exhausted. So I cannot deploy another config map in this namespace. So that means our resource quota is working as expected. We cannot deploy more than one config map in this namespace. So we can check. So there is already one config map running, that is for kubecerts. So this is how our object-based resource quota works. So I'll just delete this one. Alright, our quota is deleted. So now the second type of resource quota that we can allocate is our resource based resource quota, where we specify the specific CPU and memory limits for our deployments in a given namespace. So in this, what I have done is I've created a memory based resource quota. So here I have restricted the memory utilization to 100. So anything going beyond 100 would not be allowed in the front end namespace to be deployed. So I am explicitly restricting that in front end namespace. In total, just 100 MBs of memory utilization is allowed. Anything going over and above will be denied. So now we'll deploy this mem quota, right? All right, our quota is created. Let's just quickly have a look. All right, so we have set the limit to 100 MB. Right now, nothing is being utilized. So we are good to deploy something. So in these resource quotas, we do get the option of having limits.cpu, where you can specify the CPU utilization as well. And there is something called as limits and requests. So what are limits is? Limits is the maximum amount of resource which is allowed in a given namespace. And request is the minimum resource request that can be made by any resource at any given point of time. So right now I'm just having limit. So the upper bound and the lower bound is 100 MB only in this case. If I would have added here requests also, then there would have been a lower bound. So now we have deployed the resource quota in our namespace. Now there is one more thing that we need to look into. So this is a pod which we will try to deploy in this namespace, and this pod deployment will fail even though it is not having anything as of now. So I'll try to deploy this. Okay, it is great. All right, I was having one more object which I should have deleted earlier. All right, now you can see my pod deployment failed. So there is nothing wrong that I have done. So it has just failed. So let's see why it has failed. So it has failed because we have not specified the quotas. So this is one thing which Kubernetes ensures. Once a namespace is assigned a provided quota, any deployment that we do should have the resource utilization, the resource allocations mentioned in that object. Otherwise, Kubernetes will not let us deploy it. So what we have to do is we have to specify the resource allocation. So let me just quickly specify my resource allocation here. So now I have specified the resource limits here. So now let's see if we are able to deploy now. All right, timed out. All right, fantastic. Now we are able to deploy our pod. And the reason we are able to deploy our pod is first, we specify the resource allocation in my deployment, in my object. And second, my resource consumption that I have provided is less than the resource that are specified in my quota. If it would have exceeded this, if my pod resource allocation would have exceeded the quota's limit, then it would have again given me forbidden. So let's try out that as well. I'll just quickly delete it again. And here we will make it, let's say, 150 megs. Now let's try to deploy it. It still got the error because the limits that are enforced in this namespace are for 100 megs, and what I am giving in my pod is 150 megs, so it cannot satisfy this requirement. So it right away failed my deployment. So this is how my resource allocation works. Now there is one more concept. So suppose we have added all the resource allocation in our namespaces. Now I do not want to add this block in any of my deployment, or let's say in some of the deployments I forgot to add these resource allocations. But I do not want my deployment to fail because of that. I want Kubernetes to handle it. So in that case, what we do is we do a quota limit range. So what a quota limit range is, it is sort of a default value which will be allocated to any of the deployment that I do. So even if I am not having the resource allocation in my deployment, I can still deploy my resources, because what Kubernetes will do is, with the help of this limit range, it will apply this default range in any of my given deployment or any of my object. So I do not have to explicitly specify this. So let's see that as well. I have deleted this. I have deleted the pod as well, right? So I've removed the resource allocation from my pod's definition. Now I will first deploy the limit range. So in this limit range, what I am doing is I am providing it the default memory as 100 megs and the default request to 50 megs. So by default, the request memory would be 50 megs and the limit would be 100 megs, and it will be allocated to all the containers. So any deployment that I do without any explicit resource allocation will have these resource definition. All right, no pods. So I'll just quickly deploy this. All right, now our quota limit is deployed. So now we'll try to deploy this pod again. Now we have the memory quota allocated in our namespace. We have the limit range in place. Now we do not have any resource definition in our pod. So now let's see what happens. All right, so we were successfully able to deploy our pod. Why? Because of the limit range. This limit range is applied, and because of which these default values are added to my pod. So let me show you these values. We can also have a look at it. So we'll just describe it. We'll describe our pod. All right, now let's see. Here it is. So as you can see, these values are already added in my pod's definition. This is how our resource allocation works in Kubernetes. So now moving on ahead with our next component, that is RBAC. So when we talk about Kubernetes microservices, so in any environment, it is very crucial for us to manage the governance over the users, what user is having what privileges, where the user is deploying, what the user can deploy, what the user can delete. So all those components are very crucial. The security is very important. And using active directory integration, we have been enabled, and it has made the concept very easy to incorporate the RBAC in our Kubernetes clusters. So as I mentioned earlier, my Kubernetes cluster, the AKS is Active Directory enabled. So in Active Directory, what I have done for this setup is I have created a separate user, and that separate user will be having certain limitations on what that user can do. So let me quickly show you right now my Active Directory. So as you can see right now, I'm having my user. I've created my own user, and to this user I will be providing limited access, and that is what we will be seeing just now. So I'll just open that user up. So for our RBAC, what we are having is, for RBACs we have certain components. We have cluster roles, we have cluster role bindings, we have roles, and we have role bindings. So for this demo, what we are having is a cluster role binding, and a role binding. So what a cluster role is, a cluster role is actually a role or an authorization privileges that we provide to any object. So the cluster role defines all those privileges that are provided to any object. So as we can see in the cluster role, we have three major components. We have the API group. Any Kubernetes object falls under a provided a specific API group, and that API group we have to mention here. Then we have our resources. In the resources, we specify the actual resources which would be deployed there. All right, or on which resources I want the user to have privilege. So here I just want the user to have in deployments, and the verbs. So what all action on the resources a given user can perform. So the user should be able to get the deployments, watch the deployments, list the deployments, and create the deployments. So this is what my cluster role defines. Now, the cluster role is only defining the privileges, the actions which are allowed. Now, with whom these actions would be associated, that is something which our cluster role binding and role binding takes care. Now, what is the difference in a cluster role binding and a role binding is, cluster role binding works on a cluster level. That is anything and everything that falls at a cluster level. For example, I want to list my nodes. Now those nodes are, this action of listing out the nodes is a cluster level operation. So in order to enable that, I need to have a cluster rule in place. And let's say I just want to list the deployments in a namespace. So anything and everything that is restricted to a namespace falls under the role binding. So in a role binding, we specify the namespace. In a cluster role binding, we do not specify a namespace. As you can see, there is no namespace specified. So What we do is in our cluster role, we specify our cluster role, and then in the subjects, we will associate it with our cluster role. So we have the cluster role as Naveen hyphen role. So we have specified in the role ref Naveen hyphen role. And in the subjects, we specify the object to whom we have to associate the privileges to. So the kind would be user, and this is the object ID. So if I talk about Azure Active Directory, in the Active Directory, when you go inside any user, you will get the object ID for that user. And this object ID is what you will be utilizing in order to establish that connectivity, bind that cluster role to a particular user. So here what I'll be doing is I'll be binding this cluster role to my Naveen user, where I am getting the privileges to list, watch, get and create deployments. And in the role binding, I have done the same thing. I have restricted it to the front end namespace. All right. So first of all, let's just deploy all these three objects. All right. Let's apply cluster role first. Alright, the cluster role is deployed. Now time for cluster role binding. And then my role binding. So once all these three objects are deployed, then I'll switch my user to the Active Directory user which I have created, and there we'll be able to see what all permissions are provided, because right now I am the admin, so I can perform all the operations. So now let me quickly switch to the other user. Here I'm signed in as Naveen, right? This. Alright, so I'll quickly log in again. So using the device code, I'll log in because it is the same account which I have opened in different browsers, so that I will be having different sessions. Alright, now we should be logged in the Azure CLI. Alright, so I'm logged in as Naveen Verma. Alright, now what we'll do is we'll try to connect to our Kubernetes cluster. So now I'm trying to connect to my Kubernetes cluster. Alright, I have the conflict. Now what I'll try to do is I'll try to get the namespaces. So what I'll do is, since it is Active Directory enabled, I have to authenticate myself first. I have to verify that it's me. Alright, I've signed into my cluster. Alright, so now as you can see, I tried to get the namespaces, and in my cluster role, I was having nothing related to my namespaces, because of which I right away got the forbidden error that I cannot list namespaces. So let's try something else. Git deploy. I provided the user permissions to list deployments in front-end namespace as per my cluster role and role binding. So now as you can see, I did not get the errors, and since I'm not having any deployments, I got the usual message that there are no deployments in Microservice. So this is how we enable RBAC in our Kubernetes clusters. We can restrict the users, we can restrict the persons from doing certain activity on certain environments. So this is how we ensure a better control and governance over our environment. And this is how we enable RBAC in our Kubernetes clusters using cluster roles and role bindings. So I'll switch back to the other user. All right, easy login. All right, let's authenticate again. Here it is, right? Yes, here it is. Okay, this is not expected. All right, true. All right, we should be logged in now. So I'll get the cluster connection details real quick. So since I'm using the same machine, so I have to connect to it again so that I can have my context updated with the latest user. Alright, we are all set. Okay, so I'm logged into the different user again, who is the admin user. Yes, please. Now let's see. Notes will execute the same command. We'll authenticate ourselves again. So now with the main user, I'm able to get the objects, get the nodes. So this is how we control accesses in Kubernetes clusters. This is how we manage our rule-based access controls. We have our cluster roles. Based on that, we can define different roles, we can define different privileges and assign them to different users. So this covers our RBAC. Now we'll move on to the final topic for tonight, and that is our webhooks. Now, what webhooks are? Webhooks are more of the dynamic components which help us enable or enforce a certain level of governance in our cluster. So there are two type of webhooks. There are validating webhooks and there are mutating webhooks. So whenever a request comes into a Kubernetes cluster, first of all, we authenticate that you saw. We authenticate. Once we are authenticate, we are authorized. Then whatsoever operation that we have to do, we execute that operation. All right, and that is where our mutating webhooks come into the picture. What mutating webhooks do is mutating webhooks are majorly involved, as their name suggests, they are involved with changing or altering the object in any form. So that is where mutating webhooks come into the picture. And once those mutating webhooks are executed, then we come to our validating webhooks. Validating webhooks make sure whatsoever is going to the cluster for execution is verified, is validated as per the cluster norms and the configurations that we are having. So to enable that, we have our webhooks, and in this demo we will be going through a validating webhook and how we can enable those webhooks. So what I have done is, as I told you earlier, I have enabled policies in my cluster. So what that does is we directly integrate Azure policies with our Kubernetes cluster. And for this demo, I have incorporated one policy, and that is a Kubernetes based policy that I have. So what this policy does is, this policy will not allow me to make any deployment which is going for a host path based volume mount. So what a host path based volume mount is, a host path based volume mount directly maps my pod or my container's path with the node's path. So that is one of the security breaches that could happen in the environment. And to avoid that, we enable this policy, and this will act as our validation webhook. So if we make any deployment which breaches this validation, our validation would be failed. The validation will fail because of that breach of our policy. So if I show you the policy quickly, so as you can see, this policy will not allow any host based volume mount. So in the parameters, you can see we do not have any namespace inclusions which are exempted. We are not having any path that is excluded. So if I make a host based volume mount on any path, I should not be allowed. So that is what this policy is for. So once you enable the policy in your cluster, from here it takes around 15 minutes to get you up and running with the latest changes and the integration with the policies. So all these policies are managed by the component called gatekeeper. So this gatekeeper component enables us to get all these policies in the form of constraints and constraint templates. So what constraint and constraint template is? A constraint template is nothing but the collection of my constraints. And constraint is something that we want to happen in our cluster, or a certain level of governance that we want to enforce in our cluster. So that is a constraint that I want you not to deploy anything having host path based mapping. So that is what our constraint is for. So that constraint contains all those rules, and those rules are enforced in the form of policies in our Kubernetes cluster. So now let's have a quick demo of how it is working. So here now you can see I have a config map and I have the definition. So let me just show them in the editor. So our that is done. Let's go to Replic. We have a config map. So now what I have done is, here I'll be creating a simple config map. It is not having any explicit values. So just a standard config map with 3 simple values that I've created. And what I'll be trying to do is I'll be trying to deploy a pod. And in this pod, what I have done is my volume is of type host path. So what it will do is it will directly map my nodes directory to my container. And this is what our policy is restricting us against. So now we'll try to see if our policy restricts us from deploying this or not. Because as a validation webhook, this deployment's validation should fail. So first of all, let's just quickly apply the config map. Alright, our config map is created. So now let's do the next deployment. So I'm deploying this pod now. Alright, so now you see we got an error. And what this error is saying, that we are denied by our gatekeeper, that we cannot do a host path based mapping. So as our policy was enforcing, we cannot do any host path based deployments. So the validation for this deployment failed, because of which we are not able to deploy it. On the other hand, I have another deployment. This was another deployment which is mounting the same config map as a standard volume mount. and this deployment is created because it is not having a host path based deployment. So this is how we enforce governance in the form of webhooks. We have our validation webhooks, which help us prevent these security breaches, and we can do our custom actions also. Let's say there are some explicit requirements where I require a host path based mapping. So there in the policy we can create the exemptions of our path, our namespaces, anything and everything, as you can say. So we can have all those exemptions in place in our policy. So this is how we ensure governance with the help of webhooks, and this is how a validation webhook works. All right, guys. So we are, I believe, well over time. So with this, I'll conclude today's session for my demo. I hope you guys got to learn something new, and you guys experienced something new with microservice architectures and different components that we have. So over to you, Vishwas. Stage is yours.
Yeah, like most of these concepts, look so like Latin and Greek to some people who have never seen this, because a lot of times we know that as a developer, what do you do? A single-threaded program, JavaScript, a multi-threaded program. What next?
Yeah,
Optimizing. What next? There is always that what next which comes in your entire building process. Like, let's say, not just microprocessor, at least when you are an ML guy, you are still going to build a lot of algorithms, right?
abs- absolutely.
There is going to be a trial and error. There are going to be different ways in which you are going to do it. I think probably this is where cloud-based Kubernetes comes into a major picture, right? When once you're just doing your own managed clusters, there are complexities which are coming in. Of course, go to HackerOne, hit something called as Kubernetes in the search bar, and you'll get people have earned lakhs and lakhs together in the bounty just by
Absolutely.
showing there is a vulnerability in your YAML file, this and that. So I think probably cloud managed clusters are actually taking on the market because they know that Kubernetes is good but not perfect, and now they are relying on a cloud service provider for it. And I think this is one of the best ways in which you can learn. And this is something basic that we thought is not even like 2% of whatever the Kubernetes is all about, because there is a lot beyond what we can teach today. And I think as a build piper, we are now making sure that accessibility, that means a developer who doesn't have any form of a prerequisite for us Kubernetes can really work on Kubernetes, because we want to make sure that every piece of code which is there in your system goes through all the DevSecOps process. Things like, can we build a CI controlled version of every little build and the deploys and things like that. I think if you want all that, reach out to us at connect@opstree.com so that we'll be ready to give you a demo and you can onboard us as a partner, and potentially we can be an amazing partner for you folks as well. And I think thank you so much, Naveen sir. This is what system design, system architecture is all about. It's just that strategizing that same old YAML and the JSON, the database schema, the controllers, the ingress controllers, this, that. I think this is what we wanted as an intro. I think this is going to be a stepping stone. A lot of other topics are coming up. Every fortnight, Build Piper Show will always be there with new speakers, probably more Naveen sir as well. Let's see how it is. And it's always that learning that keeps the industry moving. And I think thank you so
Absolutely.
much for Build Piper also for giving us this platform, because we get a chance to reach out to hundreds of developers like me, you, and every person. Thank you so much, sir.
Thank you so much, Vishwas, for having me. It's always a pleasure, being with you on different shows. And of course, yes, thanks to Bill Piper for giving us such a wonderful platform to express all our views and get into such a insightful discussion.
Sure. I think, bye, folks. I think, Pankaj, I think we made an end to end demo out of all the things that we just wanted, right? You name it, we did it. So I think we covered most of the topics, and see you folks. See you next week. After the next week, this is a fortnight show, and we'll always be covering such great insights from different speakers. And bye. Bye,
Thanks, everyone.
everybody.